Okay, good morning students. The last session our discussion is about the electrolysis. Electrolysis is the splitting of a solution that is called electrolyte. The electrolyte should be either in aqueous state or molten state, which allow the passage of electricity at the same time they undergo dissociation. They are called electrolyte. And two metal rods are there, which is dipped in that electrolyte, taken in an electrolyte container called electrolytic cell. This metal rod connected to the battery. Positive terminal of the battery is called anode and negative terminal of the battery is called cathode. And during electrolysis or by the passage of this electricity, this electrolyte undergo dissociation. As a result, oppositely charged ions are formed. These ions migrate towards the electrodes of opposite charge. Those ions which migrate towards anode is called anion, charge negative, and the ion which migrate towards cathode is called cation, charge positive. And during their movement, they move to the respective electrode and they get discharged. If the gases are formed, then it is called evolution, or metal, there is deposition. Okay. And there is some slight difference in the case of electrolysis. If we take molten electrolytes, say molten sodium chloride, that contains only Na plus and Cl minus ions. Obviously, Na plus ions move towards cathode and Cl minus ion move towards anode. As a result, at the cathode, sodium metal is deposited and at the anode, chlorine gas is liberated. There is some difference in the case of aqueous sodium chloride. If we take aqueous sodium chloride contains Na plus Cl minus H plus and OH minus ions. Here there are two cations and two anions respectively. Out of Na plus and H plus ions undergo reduction faster than Na plus ion. As a result, hydrogen gas is liberated at the cathode. And out of Cl minus and OH minus, chlorine gas is liberated at the anode. And Na plus combines with OH minus to form NaOH as the secondary product. Okay. Next is about the law of electrolysis introduced by Michael Faraday, that is Faraday's laws of electrolysis. Faraday's laws of electrolysis. That is Faraday's law. Michael Faraday introduced two laws based on electrolysis. First one is Faraday's first law. Faraday's first law. Faraday's first law states that the mass of a substance deposited or liberated. I already told you that if there is a metal deposition, gas liberation. Mass of substance deposited or liberated at the electrode is directly proportional to the quantity of electricity passed. Once more, the mass of substance deposited or liberated at any electrode is directly proportional to the quantity of electricity passed through the electrolyte. If W gram of substance is deposited by the passage of Q coulombs of electricity, or W proportional to I into T, where Q equal to I into T. I is the current strength in ampere and T is the time in second. Suppose the time is provided in minute, you have to convert them into second. Or W equal to ZIT, where Z is called electrochemical equivalent. Electrochemical equivalent. Electrochemical equivalent is the mass of substance deposited or liberated by the passage of 1 ampere current for 1 second. Mass of substance deposited or liberated by the passage of 1 ampere current for 1 second. That is, when I equal to 1 ampere and T equal to 1 second, then W equal to Z. That is about first law. Then normally in a reduction reaction, suppose how many electrons are required or how many electrons are involved in that electrode reaction, that much coulombs of electricity or that much Faradays of electricity is required for the deposition. For example, Na++, 1 electron gives Na. You know, atomic mass of sodium is 23. Here 1 electron is involved in the reaction. Therefore 1 Faraday of electricity is required to deposit 1 mole of sodium. And charge of 1 mole of electron, charge of 1 mole of electron is called 1 Faraday. That is, charge of an electron is 1.6 into 10 raised to minus 19 coulomb into 6.022 into 10 raised to 23. That is 96,498 coulomb, approximately equal to 96,500 coulomb. That is 1 Faraday equal to 96,500 coulomb. And this is the quantitative aspects of electrolysis. That is, how many Faradays of electricity is required to deposit 1 mole of sodium. For that, you know, atomic mass of sodium equal to 23. That is, 23 gram of sodium is deposited by the passage of 1 Faraday. Or in other words, 96,500 coulombs of electricity is required to deposit 23 gram of sodium. Therefore, 46 gram of sodium will be deposited by the passage of 2 Faraday or 2 into 96,500. You just look out how many electrons are involved in that electrode reaction. That much Faraday or that into 96,500 coulombs of electricity is required to deposit the concerned element. Then sometimes question asked like this: how many coulombs of electricity? How many coulombs of electricity? How many coulombs of electricity is required in the following reduction reaction? The following reduction reaction, that is CO2 plus, first one, CO2 plus 2 electron gives Cu. Al3 plus 3 electron gives Al. Then MnO4 minus gives Mn2 plus. Then by the first and second equation, it is clear that here 2 electrons are involved. Therefore, number of coulombs, 2 Faradays are involved. Number of coulomb means 2 into 96,500 coulombs of electricity is required to deposit 1 mole of sodium, 1 mole of copper. 1 mole of aluminium is deposited by the passage of 3 Faraday or 3 into 96,500 coulombs of electricity. 1 mole of MnO4 minus to Mn2 plus. 1 mole of MnO4 minus to Mn2 plus. Here you find out the oxidative state of manganese both in the reactant and the product side. Here it is +7, here it is +2. +7 to +2, that is MnO4 minus plus 5 electron gives Mn2 plus. Therefore 5 electrons are involved. 5 into 96,500 coulombs of electricity is required to deposit or required for this reduction. That is manganese ion. Permanganate ion reduces to manganese ion. This is the numerical type questions based on the quantitative aspects, that is about Faraday's law. And next is about the second law, Faraday's second law. Faraday's second law states that when same quantity of electricity is passed through different electrolytes connected in series. Different electrolytes connected in series, then mass of substance deposited is proportional to their equivalent weight or chemical equivalent. Equivalent weight or chemical equivalent. Here, suppose same quantity of electricity is passed through lead nitrate and copper sulfate. Lead nitrate and copper sulfate connected in series, then mass of copper deposited divided by mass of lead deposited is equal to equivalent mass of copper divided by equivalent mass of lead. Equivalent mass of copper divided by equivalent mass of lead. Before that, anybody has an idea about this equivalent mass? Have you heard of the term equivalent mass? I think you are familiar with the term atomic mass. For generally, that is for an acid, its equivalent mass equal to molecular mass divided by basicity. Basicity means it is the number of replaceable hydrogen atom, that is the basicity. For example, HCl gives H++ Cl minus. HCl gives H++ Cl minus. Since there is only one replaceable hydrogen atom, equivalent mass equal to molecular mass divided by one basicity, number of replaceable hydrogen atom. On the other hand, sulfuric acid H2SO4 gives 2H++ SO4 2 minus. 2H++ SO4 2 minus. It is a dibasic acid. Okay, that is the equivalent mass of an acid. And equivalent mass of base equal to molecular mass divided by acidity. Molecular mass divided by acidity. that is NaOH, Na plus plus OH minus. It is the acidity, means number of replaceable OH minus ions. That is the acidity of a base. Generally, for an element, in the case of an element, equivalent mass equal to its atomic mass divided by valency. Atomic mass divided by valency. For example, Ag plus, it is monovalent, plus 1. Its atomic mass and equivalent mass are same for Ag plus. But Al3 plus, in the case of Al3 plus, equivalent mass equal to atomic mass divided by 3, because 3 is the valency. Therefore, while solving questions based on the Faraday's second law, equivalent mass, suppose instead of this already stated example is copper sulfate and lead nitrate, like that. Instead of that, if copper sulfate and silver nitrate are taken, then atomic mass of silver and equivalent mass are same. But in the case of copper, 63 divided by 2 will be the equivalent mass, because valency of copper ion is Cu2 plus. Okay, clear? That is, Michael Faraday introduced two laws based on the electrolysis. One is called Faraday's first law, which states that the mass of substance deposited or liberated at an electrode is directly proportional to the quantity of electricity passed. That is, W proportional to IT, or W equal to Z into IT, where Z is called the electrochemical equivalent. It is the mass of substance deposited or liberated by the passage of 1 ampere current for 1 second. Okay. When same quantity of electricity is passed through different electrolytic solution connected in series, then mass of substance deposited or liberated is proportional to their chemical equivalent or equivalent mass. That is Faraday's second law. Then we can do some questions based on the law of electrolysis, that is numerical based questions. That is, first one is, how many grams of copper is deposited? How many grams of copper is deposited from copper sulfate solution by the passage of 50 coulombs of electricity. 50 coulombs of electricity. That is, in bracket they gave equivalent mass of copper equal to 31.77 gram, or 31.77 will be the equivalent mass of copper. Then, how you can solve this question or solve this problem? Already, since equivalent mass of copper is directly given, 1 Faraday, that is, as per this equation, Cu2 plus 2 electron gives Cu, atomic mass is 63, for that 2 Faradays of electricity is required. And 31.7 gram of copper is deposited by the passage of 1 Faraday, or 1 Faradays of electricity is required to deposit 31.77 gram of copper. That is 1 Faraday means mass of copper deposited by the passage of 96,500 coulombs. 96,500 coulombs of electricity equal to 31.77 gram. Clear? You know, Cu2 plus 2 electron gives Cu. 2 Faradays required to deposit 1 mole, that is 63 gram of copper. Therefore, 1 Faraday gives 31.77. 1 Faraday means 96,500 coulombs of electricity. Therefore, 1 coulombs of electricity deposited equal to 31.77 divided by 96,500. Therefore, 50 coulombs of electricity deposit 31.77 divided by 96,500 into 50. That is equal to 0.0165 gram. That is quantitative aspects. That is by passing so and so coulombs, how many grams of the respective products are formed. I think it is clear to you. Okay, how many grams of copper is deposited from copper sulfate solution by the passage of 50 coulombs of electricity? Here, equivalent mass is directly given, otherwise you have to find out the equivalent mass. Cu2 plus 2 electron gives Cu. 2 Faraday gives 63, therefore 1 Faraday gives 31.77 gram. That is 1 Faraday means 96,500 coulombs that deposit 31.77. Therefore, 50 coulombs of electricity deposit 31.77 divided by 96,500 into 50. Next one, calculate the number of coulombs of electricity required to deposit 5.4 gram of aluminium when the electrode reaction is Al3 plus 3 electron gives Al. Here given atomic mass of aluminium equal to 27. 27 is the atomic mass. That is, you know, Al3 plus 3 electron gives Al. Al3 plus 3 electron gives Al. Then Al, that is the aluminum atomic mass. 27 gram of aluminium is deposited by the passage of 3 Faradays of electricity, or 3 into 96,500 coulombs of electricity. Okay, 3 into, because 3 electrons are involved, 3 into 96,500 coulombs of electricity is required to deposit 27 gram. Therefore, 1 gram of aluminium is deposited. 1 gram of aluminium deposited equal to 3 into 96,500 divided by 27. Here in the question, 5.4 gram of aluminium. Therefore, 5.4 gram aluminium deposited by the passage of 3 into 96,500 divided by 27 into 5.4. That much amount of electricity, that much amount of coulombs. That is 57,900 coulombs of electricity is required to deposit 5.4 gram of aluminium. Okay, these are the main numerical based questions regarding Faraday's law. I think that is about the lesson as per this year's syllabus. Okay, the remaining thing in your textbook, in addition to this, you can see that as I already told you that some cells, batteries, it is otherwise called batteries, type of cells, primary cell, secondary cell, fuel cell, and finally about corrosion, the electromechanism of corrosion by using this electrochemical theory, like that. Okay, here we mainly concentrated about the galvanic cell, and based on the galvanic cell, how to represent a cell and reduce the expression for Nernst equation in the case of a cell. How does it related to the equilibrium constant as well as the EMF of the cell, and so many numerical based questions based on the Nernst equation. Okay, then next part is about the conductance of electrolytic solution, resistance, conductance, like that. Okay. And as far as this physical chemistry part, one of the most important chapter is this electrochemistry, and one more thing, next lesson is actually chemical kinetics, or next class I will start chemical kinetics or some chapter from organic chemistry. Okay, one by one organic chemistry, and otherwise I will continue this first lesson. Okay, thank you all.